Hello everyone, my name is Alan WinkelBauer. I'm the Chief Designer here at EAD Engineering, and today we're going to go over BIM. Does anybody have any questions before we begin? Alright, so we're going to do it's going to be like a high level, but we'll get started here. So the course objective, this course is to get you familiar with BIM and the many different interfaces. The target audience, this course is intended for engineers, project managers, and construction managers. Students who complete this course will successfully be able to define or know the definition of BIM, identify the different types of BIM products that are available today, see what BIM products EAD uses and decide to use and why, or what that we use and why, and to classify different LODs, which is the level of detail that BIM models represent and what they mean. Anybody have any questions? So the content, what is BIM? Different BIM programs used, what BIM programs EAD uses, project processes, LOD, benefits of using BIM. What is BIM? In a nutshell, basically BIM is, in recent years, more architects and engineers have made the switch to building information modeling, which is BIM, as engineering tool. The reasons are quite clear. BIM encourages more collaborative environment and has strong features related to sustainability and constructability during building design, and furthermore, they cut down much of the manual work. Our teams become more productive, and the BIM methods save money for our clients. Some examples I would have to say would be drawings that you see on the screen, like the sheet files that we create. They're not just 2D images, they're actually pictures of the 3D dimensional model that's in the background. More modeling time is used up front, and that's been the big stickler that people see is why I need to see these sheets. I need to see why where we're at, what we're doing. But on the back end of the project, you get more drawing production and a lot less time at the end of it. And there's also interference resolutions prior to reference, and then automated drawing schedules, equipment lists, and bill of materials can be drawn out of these models as well. What does BIM stand for? Building Information Modeling. This means the project information lives inside the model. The architectural, you have wall types, door types, windows, flooring, etc. Structural, beam sizes, foundations, and bracing. In the mechanical side, HVAC, utility piping, equipment, and pumps. And on the electrical side, MCC panel boards and conduits. Does anybody have any questions at this time? All right. The different types of programs that we'll be using, or that are out there, are Autodesk Revit. You have Graphisoft, ArchiCAD, Naviworks, Allplan Architecture, Gentry Technologies, Naviworks Vector Architect, Bentley, 4MSA, IDA, which is Architectural Design, IntelliCAD, CADSoft, Envisioneer, Softtech Spirit, Rhino BIM, and Procore. Does anybody use any of these besides Revit? Okay. So BIM for piping and instrumentation diagrams, there's also Plant 3D/Smart P&ID, which is actually one Autodesk product that does both of them. And this gives us the ability to get equipment lists, line lists, valve lists, and instrument lists. So BIM programs at EAD, we use Autodesk Revit. one of the big reasons that we use it is it has a parametric model. So what I mean by parametric is if you change one thing on the sheet, it's not just changing something on the sheet. You're actually changing the physical model in the background, which is nice because if you have section cuts, details, and different pieces of equipment that you want to put in and see how the fit and finish is, not just if you're putting it in the sheet, like as if you're going through the window, but you can it actually changes the model in the background. So there's only one place to change it, but it changes throughout the whole entire project. Sheet creation in organizations. Again, it organizes all the sheets for you, and the views are easy by adding organizing sheets and views that are easier. You can also apply view templates to make seeing your architectural, mechanical, electrical, and plumbing views consistent in appearance, so it doesn't look like more than one person try to draw your set for you. And then there is a common central file. So the disciplines use each other's files as backgrounds, and they can monitor their model and let you know when something has changed so you can rectify the potential interference issues. Multiple users. More than one user can be in the project at the same time. Standardization, the project templates, the drawing look, the way they are drawn by the same, so they all look like they're drawn by the same person, and they're very consistent. And in the end, it really is a better product for everybody. Model sharing with other firms and vendors. Models can be shared in many ways. Models can be updated once or twice a week, or current active models can be stored on the cloud by using the Autodesk Design Docs. So you have various design teams and members that can collaborate with one model in real time. I know here at EAD, when we do that, we have like 5 or 6 different users that will be in one of our models at any given time. We run like an architectural model, we run a mechanical model, and we run an electrical model. And what we've noticed is the collaboration between the groups. It's a lot more streamlined. Everybody can see what the other person is doing, and it's really cut down on interferences that we could see in the field. So now to get into the different types of LOD. So the different types of LOD, so you have an LOD 100, which is pre-designed, which we like to call concept. And that's more of just like your blocks, throwing in, I don't want to say it, your areas that you want to get a good idea of what you're looking up, or what you're trying to build. LOD 200 is schematic design. Now we're starting to see a little bit more definition in the models. You have level 300, which is your design development. Now we're starting to get in, our pocket's been more defined, our equipment and everything we have is starting to get laid out. It's starting to look more like a plant. Level 350, this is when the construction documents come into play. Now we've gotten submittals back from vendors on certain pieces of equipment. Everything's starting to take shape. The fit and finish is starting to get there. It's looking like a construction set of documents, and you're ready to issue. Now level 400 is your construction stage. Phasing can be part of this. For if you're trying to build one portion of your plant, and then you move to the next one, you can start phasing these in and out. They can have staging areas for your materials and everything. And then LOD 500 is typically your as-builts. This is how everything has been installed and it's ready to go. I would say one caveat to this whole thing is here at EAD, typically our LOD is between a 300 and a 350. We do furnish as-builts, but when you start getting into the 400, that's when like the bolt sets, how many washers are in our plant. We haven't gotten down to that detail level just yet, so we like to stick around to 300 and 350. So now we're going to get a little bit more descriptions. Now if you look at, here's LOD 200, you can see that we just got basic pipes. LOD 300, now we're starting to get more of a feel of what kind of instrumentation and valves are going to be coming in. LOD 350, now that's getting a lot more defined. You're starting to see insulation on the pipes. Your ball valves, your actuators looking like like they're supposed to, your strainers. LOD 400, you'll start to see populating like bolt sets and everything. And LOD 500, now you can see how, oh, they got a disconnect on the wall. Everything starts to come together. So LOD 100 pre-design, the building 3D model is developed and represented to information on a basic level. Thereby, only conceptual model creation is possible at this stage. Parameters like area, height, volume, location, and orientation are defined. When we go to LOD 200, the schematic design, elements are modeled with appropriate quantities, size, shape, location, and orientation. Non-geometric information can be assigned to the model and the elements. LOD 300, accurate modeling of the shop drawings and where elements are defined in specific assemblies, precise quantities, size, shapes, locations, and orientation. The non-geometric information is updated for the model and the elements. LOD 350 on your construction documents includes model details that represent how the building elements interface with various systems and other buildings elements with graphics and written definitions. LOD 400, construction stage. Elements are modeled with specific assemblies with complete fabrication, assembly, and detailing in addition to precise quantities, size, shapes, location, and orientation. Non-geometric information and model elements continue to be updated. I think it's important to note that during the LOD 400 stage, when we set a structural package out to a vendor, they can take our drawing, and if you have an LOD 400 level of detail in your drawing, like the bolt holes, coping on the flanges, that will actually be shown in the model, and they can actually take those and integrate that within their software that they use to cut their beams and assemblies with. You could technically, I mean, we haven't done this yet, but they would be able to create all of these beams, cuts out on the field, bring them in, and pretty much just have everything cut without having to redraw any of our information that we already shown. Construction drawings are easily adjusted to match construction phasing. Like I said before, you can take a set of drawings, and if you have a phase 1 where you have a demo, a phase 2 where you're starting to build a new section, but now on the phase 2 you also have another demo and another area to keep everything rolling, you can phase all of that in, and you can see how everything is going to be built. And it'll separate your bill of materials for those phases as well. More on the construction stage. A key difference at the LOD 400 is trade scheduling. At 100 through 300 levels, different disciplines are completing design stages at different times. For example, structural steel and foundations will often be at least one level above and the other disciplines, followed by the architectural elements, and lastly by MEP. In LOD 400, all disciplines will align instead by physical area, such as by floor. Coordination must continue throughout the 400 phase. All parties should be included in this coordination, and no fabrication should begin until the entire team agrees that an area is ready. The result of level 400 coordination will be the installation certainty through coordination of all trades. LOD 400 models can also be used for material staging and other necessary construction planning needs. LOD 500, this is the as-built stage. Elements are modeled as constructed, assemblies for maintenance and operations. They will be geometrically accurate, not showing excessive fabrication level of detailing. Objects will contain their actual record cost data, purchase document links, commissioning data links, maintenance requirements, which is a link or data, the object-specific data, as well as FAN CFM, as well as any other data relevant to the life cycle management of the building and equipment. So essentially, if you have an LOD as-built, all of the information for the pieces of equipment that you have in there will live inside that model. At the end of this, if you ever have another project that has started in one of these areas or just off to the side of one of these areas, you can still use this model as your base model and then add on to it. So essentially, your Revit model will become a living document for your plant. Now, what it means by the links is if you have a PDF of a piece of equipment for their cut sheet, all of that can be linked in, just like in AutoCAD now. You can link that in, like hyperlink it, and it'll have the data there. You can also have that information live inside the model. When you click on the piece of equipment, you can see what is actually going on in the background. Benefits of using BIM. What are the minimum benefits of using BIM? Time savings. The parametric components change things in any view and updates in real time. Has anybody ever had any problem with when they're drawings right now for updates if you're using 2D? Okay. There's no repetition. A piece part, the door numbers, equipment numbers, etc., you don't get a repeat on them. Once you've put the pieces of equipment in and everything kind of flows. You will notice that it will not let you duplicate numbers. If it does, it'll let you know, and then it usually puts a question mark behind it to say that you have an error or there's something that's duplicated. So it makes Singular Database offers several other benefits, changing the model in only one place instead of each component on the several sheets. Like I mentioned before, if there is a change inside of your model, that change can be done in one spot, be it in the 2D view that you're looking through the window, or be it through the 3D view that you see. That one change is there. Tags on equipment. So the annotation through the project change the annotations through project change at once because the information about the equipment is stored in the family. If you have tags that are already on your drawings, you move that piece of equipment in an elevation view, that actual tag and that equipment will move, and so the information stays with it. If I've had a piece of equipment that is actually dimensioned inside of a model, and on your sheets, and it could be from an elevation, it could be from the plan views, all of that information that was with that piece, the tags, the dimensioning, if I erase that piece of equipment, all of those annotations go away. Throughout the whole project, not just on that sheet you're working on. They will remove themselves through the whole project because they're tied to that piece in the model. What are the benefits of using BIM continued? Huge family. The model components in the library. Many manufacturers have already created many of their own components in Revit, and they are readily available to download off of their sites. Another twist in this is the families and the components that have been created for the project are stored in a file that can be exported to other projects. Now, even if you did a family inside of Revit, inside of your project, you can always export that out, save it to somewhere else. Here at EAD, we have a place on our server that it's basically a suppository that we can put all of our Revit families. We have ours kind of separated out, for architectural, mechanical, electrical. Sometimes it's by client, depending on what the piece of equipment is, but it's very handy that you don't have to draw one of these over more than once. 3D model is a byproduct of drawing in Revit. It is true. When you're physically actually drawing in Revit, you're actually drawing a 2D model and you're given a height and a depth. It makes it easier for people to pick up on. It is a very intuitive software. You can walk around the model in VR for interference checks and markups. Here, recently, in the past 6 months, we have purchased a pair of VR goggles, and we use Iris VR. I don't know if anybody's ever heard of it, but Iris VR allows us to physically walk through our model in virtual reality, and we can actually mark up inside there. Once we're done doing our markups, we can export those markups as a PDF and then send it to the design team. And then the design team has an idea. They know where they're supposed to go and change, what the problem was, or what interference or issue there was. This is a second, we use Naviworks Manage right now for interferences, but this is more of a, is the fire extinguisher in the right spot? Are the light switches where they're supposed to be? Do we have any interferences on our walk path going between these conveyors? It really brings, it really opens your eyes to the surrounding area that you have already built. So it helps out tremendously when you're just kind of going in. And not only that is what we've noticed as clients, they like the idea, at first they think it's more of a gimmick because, oh, I'm going to throw a set of VR goggles on, I'm going to walk this, is that really necessary? But what they don't understand is once you get inside there and you immerse it, you look around, it's a very powerful tool to get everybody on board, and it's great for visualizations. If you have anybody on your team that cannot visualize anything, this is a great tool because they can physically see it in space and what it looks like. So it's pretty cool. Model becomes an as-built for the project. This is true. So as we're going through, we were talking about LED 100 through 500. That whole time we are still using just one model. And that one model is still a very powerful tool. And at the end of this, the clients, they get their model, and then, like I said, as soon as another project starts, you can use it as, you can start up a new project and use that same model in the background, so you're not redrawing or trying to recreate the wheel on all of your facility needs. When the project is complete, you have an accurate model of what has been built. You can use your model for future projects. What can project construction managers use to view the model? That's a good question. Has anybody, like Autodesk Revit is one of the tools that we use, obviously. You can go in and spin around in the model. Bluebeam or Adobe Acrobat. Basically, in Bluebeam, we run Bluebeam as well as a part of our software package. We use it for our Q2 reviews. But what we also like is the CAD version of the Bluebeam gives us tools inside of our Revit model, or inside of Revit, to create 3D PDFs. And I don't know if anybody on the phone has anybody tooled around with a 3D PDF. Okay, so the 3D PDFs, they're pretty nice. When you can kind of, how do I put it? You can view the whole model. You can cut sections with it. You can look at it. And if we have a little bit of time after this, I probably can show you what that looks like. Exported 3D PDF for viewing. Model content and Smart comes through, so you can see what has been installed. Design review from Autodesk. Exported DWXF model from Revit. The model content and Smarts come through, so you can see what has been installed. Again, even in these programs, if you click on a piece of equipment, or click on a wall, or click on a door, it doesn't matter. It will tell you what it is. Structural steel sizes, it'll tell you what the member sizes are if you have those up. So even though you do not have Revit, this is still information that comes across in the design review. And this will also come across in the Bluebeam as well. Naviworks Freedom, which is free. So Naviworks has one that has Freedom, Simulate, and Manage. Exported NWD file for viewing. The model content and Smarts come through, so you can see what has been installed as well. Does anybody have any questions on that one? Okay. This is a type file, can also be, that has an expiration date. I forgot to mention that. if you have a Naviworks file, you can set it so after a week or two is unreadable. This kind of verifies that somebody's not looking at an old model. I can see it in a situation where if it's a bigger project, you send an NWD file to a project manager, they're sitting there looking at it. A week later, you send another one, and then you skip one, or they don't get the one in the week, or they open up the wrong one. It kind of eliminates that problem, because if you give them like a week expiration date, they can't open it, they can't view it, then they know that they have to go look for the newest one. And Procore, so this is new. I don't know if has anybody on the phone used Procore?
I have.
Do you like using Procore? Do you use it often, or is it just a little while?
It's okay. No, I've just used it once or twice, but
Have you?
yeah,
Okay.
it seems okay.
So Procore has a new feature, and it's a BIM viewer. It's the same thing. We can download the model to that, and you can actually the one that's in there. You can view these models now in Procore. So that's a kind of an add-on tool that they did. So that's pretty neat. We've noticed that we've had Procore here for probably 2.5 or 3 years, and they keep growing. We're all still kind of getting used to it, but it really is a powerful tool. This gives the user ability to view a model on iPad and on the site in either 2D plans or the full 3D model. And what that means is technically you can click on the bubbles, like inside Procore. If you're looking at a 2D image and it's from a Revit file, you can click on the bubbles and it will take you to those views that are on those sheets. So again, that's a pretty powerful tool that you can use for people out in the field. So, in summary, so hopefully you have a better definition of BIM. Hopefully you can identify the different types of BIM products that we use today. Hopefully you can see the BIM products that the AD uses and classify the different LODs and level details that BIM models represent and what they mean. On that note, if we're doing this on site, you'll be able to walk through the goggles with us. I left that slide in here. This is just one of the facilities that we did, and it's pretty cool. Do you guys have any questions?